Okay, I think we are live. So, welcome everyone. It's great to see you back. My name is Atik. I am the CEO of Proya Software. As you know, it's great to see that the interest in COMOSYS is alive and kicking, and that's what we wanted. You've all seen what COMOSYS can do, and now you're excited to see what else we've been adding what else we've added in the last year. You're here because you want change, and that's apparent. That's very clear. You're here because you want better technologies, and you're also here because you want the better technologies at a cheaper price, and that's what we're here to deliver: a better technology at a cheaper price. So please be patient, and please bear with us. It's going to be a very nice presentation. Please write your questions in the questions area, and we will try and take up those questions towards the end of the webinar. I just want you to relax and enjoy the next. It's going to be a slightly long webinar as always. Unfortunately, whenever we plan a small webinar, a short one, we end up having a slightly long one. So this one is going to be of reasonable length. I just want you to be patient and just enjoy the presentation. Thank you, and I think we can start.
Hello, everyone. It's great to be back. It's been a while since we did our last What's New webinar. I would like to begin by sharing with you all how excited we are with our new release, which is COMOSYS 2024. As you will see in the rest of this webinar, we have focused on many different areas, but the real emphasis has been on the customizability of the software. We strongly believe that this is one of the areas which allows the best softwares to scale up and meet the challenges of all types of customers. All countries are different. Design preferences within countries are different. In short, almost everyone does things their own unique way. In this regard, we have initiated a major push towards complete customizability. COMOSYS, as you very well know, is already very customizable, but we want to take it to its logical end. In this webinar, I'll be showing you many new features in this regard. Of course, there'll be many other features as well. We have improvements all over. We have improvements on the steel modeling side. We also have improvements on the concrete modeling side. We also have the seeds of precast concrete to share with you. There are many improvements on the drawing sides as well. And then there are some general improvements. All in all, this is a major release, and we are sure you will enjoy today's presentation. Now, without further ado, I would like to start the presentation. Now, the first thing which I want to talk about are what we call user-defined attributes. Now, you see them under the Edit menu. On the right-hand side, you have this little button called UDA, which stands for User-Defined Attributes. And I'll explain what they are. Now, imagine any object. So imagine a frame, for example, the profile, or it could be a plate, or it could be a bolt, or it could be anything, basically. And you know that out of the box, off the shelf, when you buy COMOSYS, there are many attributes. When you double-click on the profile, for example, it has many attributes. These are off the shelf built in, for example, the profile name, or it could be the material, or it could be the profile type, or it could be other things like detailing related, their numbering related information, etc., or the design related information, etc. All these are obviously off the shelf attributes, and these are given with the program. But what if you needed certain specific attributes which are not available over here, and your project required them? Then what would you do? So what could be examples of such attributes? So for instance, they could be design related. So for example, you might want to know who was the engineer who designed this particular profile, or some information which is related to the design process. or it could be related to the manufacturing process. You might want to know at what stage of manufacturing is this profile? Has the material been ordered yet? Has has it been sandblasted or cut, or has it been drilled, or has it been painted, or has it been sent to the site? You could also want to know at what stage of construction or erection it is. So, I mean, depending on, you might want to have certain design-related information, like whether the paint applied on this piece will be a normal paint, or will it be a fire-resistant paint, or some other kind of paint. So all sorts of requirements can show up, and as you will appreciate, it's impossible for software to provide every single possible attribute which you might need in your project off the shelf. So when you think about this globally and for large projects, it becomes an increasingly important requirement that the user be given a capability where they can define their own attributes and then kind of use them as if they were provided off the shelf. And that's very important, the ability to then use these attributes later on in different let's press this button over here. Like I said, it's under the edit menu. And when I press this button, this dialog box opens up. And I want to go through this dialog box slowly so you can understand how UDAs are used. Now, the first thing I want to talk about is what are the different types of attributes which you might need. And this is the type variable over here. And if I open it, you see that it says it can be a text, or it could be a text list. It can be an integer, or it could be an integer list. It could be a numeric value, or it could be a numeric value list, or it could be a Boolean, which means it could be a true false type of attribute. Now, what does it mean? A text basically means that it's, maybe it's somebody's name, or the name of name of a company, or name of a vendor. Whenever you're going to write it down using text, then that's a text field. So the type of the attribute is a text type. But it could also be a text list, which means that you want to limit the input to only particular texts. So let's say you have 5 vendors who are working on the project, and they have specific names, company ABC, company DEF, whatever, 5 different names of companies. And you don't want to leave those names open, like, you'll have maybe many users working on the model, and each might, they might make spelling mistakes. They might enter the name of company one differently. Some might enter it differently, the other person, or the same person might enter it differently in different places. So you want to kind of limit their choices. You only want them to choose from a list of 5 given companies. So in that case, it will be a text list rather than an open text field. If you want it to be random, different every single time, then you'll just leave it a text. If you want it to be chosen from a specific set of text variables, then you will use the text list. Similarly, if the attribute is an integer, and you don't want it to be something with a floating point, then you will use the integer field. But if you also want it to be specific integers only, like you want the value of that particular attribute to be, say, either 1 or 7 or 15 and nothing else, then in that case you would use the integer list, in which case you will specify what those integers are, and then the user will select from only that list. And similarly, you have the floating point values, or a floating point value list, which we call a numeric value or a numeric value list. Or the last option is that it could be a Boolean type, so it could be a true false type variable. Now let's do a small example just to see user-defined attributes in action. So I'm going to start by entering. So there's something called a group caption. And without explaining what it is, let me just give it a name over here. So for example, let's call it finish related variables. This is like the caption under which you can collect more than one user attribute. So, but they'll all be of the type finish. They could all be related to the finishing which will be provided for that object, for example. So let me just give a name. Then this is a caption name, and that particular one the first attribute of belonging to the caption finish, I can call it surface finish, for example. I can give it a label, which can be the same as the other one. It can be different. This is just basically a text. I can call it a text list, for example, because I only want the user to select from certain types of finishes rather than allowing him to, write a random finish every single time. And when I say text list, the next thing which I choose over here is to which types of objects will this user-defined attribute be applicable for. So, for example, I could say that I will use it for profiles and plates. In COMOSYS, we have many different types of objects, and the most relevant ones have been listed over here: profiles, plates, solids, rebars, and bolts. You can have user attributes which apply to all of them, or to certain a particular one or two. So in this case, I'm choosing that for plates and profiles, I'm going to have a field called finish. I'm going to have a group of fields under the group caption of finish, and the first one is called surface finish, and it's a text list. And because it's a text list, it's like an enumerator. And over here, then this items thing opens up, and we have, because it's a list, I have these 3 dots over here now. And when I press them, this little box opens up, and I can write over here what the different options would be. So let me write those options. I've written 2 options. One is normal paint, and the other one is fire resistant paint. And I'm going to say OK. And when I do that, then these are now entered inside this little group. So now that I have defined my first UDA under the group caption of finish, and I've entered all the relevant information related to it, I can just press this plus button. And when I do that, whatever I've just entered, this group caption, name, label, type, where it applies, and the enumerator values, is then added as my first user-defined attribute on the left-hand side. And I can say, press the save button now. So it just warns me that it's an undoable action. I say yes, and it saves it. And I can close this box, and my first user-defined attribute will have been defined. Now that we have defined our first user-defined attribute, and if you remember, we've assigned it to profiles and plates. Now let's try and use that. So let me just double-click on any profile over here. Let's say this one, and this is the normal. This is the dialog box which opens, and we have certain tabs defining the various off-the-shelf attributes. But now you will see this tab called the UDA tab. Which means that there are user-defined attributes related to this object. And when I go inside this one, the UDA tab, I see that now right now there's only one caption called finish. We could have multiple options depending on how many group types we have defined. In this one, we have only defined one caption, which is finish. And under that caption, we have defined only one variable called surface finish. We could have multiple variables under the finish section, under the finish caption. We could have 10 different variables in whatever order that we wanted them to be. And inside surface finish, we've given it the option of either normal paint or fire resistant paint. So I could choose fire resistant paint for this one and say OK. And now, let's just go ahead and select this one and this one and this one, remaining 3 over there as well, and give these the fire resistant paint option as well, like that. And now on this floor, for example, or in this building, the others have nothing. So if I were to double click on any other one, this one has nothing assigned to it. It has the ability to assign a surface finish to it, which was not available off the shelf, but nothing has been assigned. Whereas this particular beam over here, if we go inside, it says we need fire resistant paint on this particular beam. Now, just to quickly show you that this is not limited to just one UDA, I've quickly assigned several. So I've assigned 2 UDAs now under the finish caption. One was like we did together, the surface finish, and I've added another one called sandblasting type. and I've defined a new group caption called the erection contractor, and I've given it the contractor's name UDA, just to show you what this looks like now. And if I were to now double click on this beam over here, you will see that now we have two tabs over here. One is the erection contractor tab, which wasn't because I hadn't added it, and the finish one. And the finish one now has two user defined attributes under it. And like I said, you can have as many as you want. You can have 10 different variables over here. You can have 10 different tabs towards the side, as many as your project basically requires. And you can then use them in different parts of the software. Now, obviously, you can tell that these user-defined attributes are extremely important. They really give you a lot of customizability, a lot of flexibility with your project. It gives you the ability to really deal with large-scale projects with very varied amounts or types of data in it. And I've shown you how you can basically create as many user-defined attributes as you want. And now, obviously, once we've created them and defined them and assigned them to the variable, to the different objects, which, like I said, you can assign them to your profiles, to your plates, to your generic solids, to your bolts, or basically any object type which you have, you can assign them. And once you've assigned them, you want to obviously use these user-defined attributes. And there are three main areas where you will use them. And the first one, and the most obvious one, is that you use them for normal model side or drawing side filtering. Now, filtering is extremely important with large projects. As you know, when you're working, you want the ability to see only what you want to see on the screen or on the drawing. So that's why we have view filters, and that's why we have drawing filters, which you already know about, which are very advanced in COMOSYS. So now I want to show you that when we go into the filter, this is the view filter, for example. Obviously, you have the same thing on the drawing side as well. But when you go into the view filter, we now have a UDA tab over here as well. And we can now filter according to the user-defined attributes we have just created. So for example, if I were to go down here and I say I've created these two group captions, one was called finish, if you remember. And inside finish, we had two different, the surface finish and the sandblasting type, which I had added later. Let me go to the surface finish one. And let me call it because it was a text list, if you remember. Let me select the equals operator, and because it was a text list, I now don't have the ability to just write anything random, but I have to choose from the selected from the given texts which were already entered. So let me choose the fire resistant paint over here. And once I've created this filter, let me press this plus button, and I can add it over here to the top. Basically, whatever I add to the top, those will be the filters which I can then use for my filtering. Let me create another one, use the erection contractor, the other one, which I created, which I didn't show you, but I have assigned it to certain beams. The contractor's name, which will be responsible for the erection of certain beams on the site, and we can call it equal, and we can say, let's call it the Steel Smart. There are three contractors working on the erection of this building, and I've selected certain beams over here, and I've assigned those beams to this particular contractor, and let me assign that as well. Now I've got two filters up there, but I don't want to use both of them. I just want to see, if I select this one, this means I want to see which ones have the fire resisting paint. So if I don't select them, this one is not in play. Only the one which is selected is in play. When I do that and I press OK and OK, immediately only the beams which have fire resistant paint are then left on the screen. Similarly, if I were to go back and change this from this to this, now I have the other one in play. And now I see that these are the beams which are going to be erected by the contractor called Steel Smart. So this is a very handy way and the most obvious way of using the user-defined attributes. Like I said, there are two other places where we can use them. And I'll just mention them at this point because I'll be talking about them in detail when we get to those topics. And the first one is in custom tables. On the drawing side or in the reports side, we have now in this version, which I'll show you later, the ability to create custom tables where the user actually chooses the fields which will appear in the tables. And these could be material lists or bolt lists or rebar lists or anything basically. And where you define these custom tables, you also now have the ability to include these user-defined attributes in those tables. You can actually use those user-defined attributes for even adding them and giving totals and subtotals and things like that. So that's the first thing, which I'm not going to be showing that right now. I'll be showing that in later on in the webinar. And the second area is the custom annotations. So the custom tables and custom annotations. Both in the custom tables, we can use these user-defined attributes, and also in the custom annotations, if you want to annotate these profiles, if you want to annotate certain plates or bolts or rebars in a different way on the drawings, once again, we have the ability to use these user-defined attributes. One thing which needs to be mentioned at this point is that these user-defined attributes are basically saved in the form of XML files. And what's good about these XML files is that you can take these XML files, for example, and store them away in the company folder, company settings folder. And if you do that, then any new model which you create will automatically have these user-defined attributes. So you won't need to redefine them every time you create a new model. So any user-defined attributes which you feel that you will be using again and again in all your projects, you can simply store them away in the company settings folder. Otherwise, if they're not going to be used every time, then what you can do is you can store them away in the model folder, in which case only that particular model will have it. And if you have these XML files in both the company folder as well as the model folder, then what COMOSYS will do is it'll just merge those XML files together and take the user-defined attributes from both the files and give you a consolidated set, which can then be used in that particular model. Now I would like to talk about an import feature basically, which is to do with what we call reference models. But before we get into that, I would just like to remind you what we already had in the previous versions. If you remember, in the import export section, we have under the import heading, we have various options like IFC, NDXF 2000, CDFX, etc. But these would normally just bring in, let's say we imported an IFC, it would bring in the entire IFC and convert it into the local objects, and that would be it. But with this version, what we have implemented is something what we call reference models. And reference models can make your work a lot easier in certain ways. What they can do is they can provide you with certain capabilities, which I will talk about. Now, before we start into all that, I would just like to say that instead of going to the normal import area for importing your IFCs, what you would do in the case of reference models is that if you look at on the left-hand side, we have our tree view. And if you remember, we had these groups, and now we have this thing called reference models over here. This wasn't present in the earlier versions. And under the reference model, we have a default group. When you open a new model, you will have that over there. And you can use that to then subsequently import any reference models. And now we will talk about the details of how you do that. So let's start with that. The first thing I want to say is that these reference models are very similar to the groups you're already familiar with. Just like you can create as many groups as you want under the Groups tab, you can create as many sections as you want under your reference models, and then you can import as many models as you want under each subgroup. So you're provided with one subgroup to begin with, which is called default. you can right click over there and you can say add new group, and you can create groups under that as well. But let's not go into that. Let's just click on the default subgroup and right click. And we see that in the options we have is to add an IFC model or add a DXF model. You can see them over here. So these are the two types of reference models which are supported at this moment in COMOSYS. Obviously, the most used one will be the IFC model, but you can also import DXF models. So let's do that. What we can do is we can try the IFC model first. If you click on that, you see that you're familiar with this IFC import dialog box, which is very familiar to the normal IFC. So I'm not going to go into the details of what that means. You can see videos, training videos regarding that. But let's just click on these three dots over here so that we can select the IFC file. It's also allowing you to change the subgroup over here once again if you want to, but we've already clicked from there, so it's chosen that. So let me click on these three buttons, and let's go to our wherever we have the IFC file. Let's say we have an IFC file which we want to import as a reference model this time, and we click on that and we say open, and we can change the settings. I'm not going to go into those details because that's not the purpose of this presentation at the moment. I just say import, and it starts importing that particular IFC file as a reference model. Now you may be thinking, what's the difference between importing it as a normal IFC file and importing it as a reference model? So there are a few differences which make working with reference models a lot easier in certain ways. To begin with, for example, if it was a normal IFC import, I could have deleted any object. But in this case, for example, if I select this object and I press delete, it's not going to delete it because it's either one or all or nothing. It's the whole, the entire reference model needs to be acted upon by the user, and only things you want to do with the entire model are possible. So what are those things which are possible? So if I were to open this now, you see we now have this reference model listed under the default group. If I double click on that, you see that it has it's an IFC file. It tells you where the IFC file resides. It tells you under which group, the default group. It has a name. You can add some descriptions and stages and sources, some extra information if you want. What's important is that you can give it an offset. For example, if I were to give it an offset of 30,000 in the X direction, then what can happen is the entire IFC file gets shifted by 30,000 in the X direction. So that is something which isn't possible after importing from the normal IFC, because that is a one-time import, and once it's imported, it's done for. But over here, as you can see, you can give an offset to the origin. What you can also do is you can give a scale factor. So, for example, if you imported by mistake using the wrong units, for example, it was supposed to be millimeters, but you imported it in centimeters or something, then even after importing, you can now change the scale as well as the rotation. And it also gives you information on when this file was last imported. So, for example, if the file changes, if the IFC file changes in the folder where it is residing, you can re-import it from there as well. Now you have something called custom draw type and a custom color, which means that, for example, you can, by default, it will basically use the default of the system, but you can convert it into wireframe if you want, in which case this particular model will always be drawn in wireframe, no matter what the rest of the drawing settings of COMOSYS are. As you can see, everything over there is now drawn in wireframe. What else can we do? We can change that to any, like I said, you can change that. You can also change the custom color. So that means you're telling the system to override the color which the IFC file had provided, and basically turn it into something else. So you could turn it into the gray, for example, if it was a reference structure nearby your structure. And that is something which you would be able to do. And the important thing is that the entire model is at your disposal over here. And if you want, you could right click on it and you can say hide. And in that case, the entire model is hidden from you. It's a very quick way of filtering. Had it been normal IFC import, you would then need to continuously manage it by selection and all that. But in this case, you can just right click again and say show, and the group and the entire reference model is shown on the screen once more. So this is the basic advantage which we have once we have the entire reference model under automatically saved under a group. We can, like I said, we can show it, we can hide it, we can even update it if the source file changes, and we can bring it back in. We can delete it, we can remove it from our list of models, and we can re-import it later. But the idea is that as long as we don't delete it, we can have as many models as we want under the reference model tab, and we can manage those models by just right-clicking them and showing them or hiding them or updating them as we need. Now, not in this version, but very soon we will be having change management implemented into this as well, which means that when you update a model, when the source file changes, it will show you which particular objects have changed from the last import, and which ones were added, which ones are deleted, which ones have been modified, etc. So the entire change management system which exists in COMOSYS will be implemented to this particular feature as well. And then we will have, because it's impossible to show the deleted items, because if you delete them, then there's nothing left to see. So it will basically temporarily show you those items, that these items have been deleted from the last import. In the previous import, they existed, but not in this one. But then it'll also give you the option of deleting them once you've seen them. So it's a very nice way of importing your IFCs as reference models. Unlike obviously one difference is that these are now just generic solids, and they're not converted into native objects. If you want to convert, if you want native objects, then you will have to use the original IFC import, which you're already familiar with under the import menu. Now let's go ahead and import another reference model. As I've said before, you can import as many reference models as you want, and so let's import another IFC model, and let's go to our samples over there. We can go to maybe tabs or maybe some other one. Let's go to an AutoCAD model and import an RC building, for example. And we can just say import, and the building is imported. It's wherever it is in the current units. We can, if you go and double click over here, we now see that we have two models over there, the earlier one and this new one. We can double click on this one. We can give it a Y offset of 10 meters if we want, for example. Maybe the origin has not been brought in properly. What we can also do, like I mentioned, is we can give it a rotation of, say, 35 degrees. And in this way we can continue importing in our reference models, and we will keep collecting them on the left hand side. You can have 10, 12 different models. Now obviously when you have these reference models, then you can work with them. They're all snappable points. So for example, if I were to enter a beam, I can snap from this point to this point, and my beam will be created. I can snap from that point to that point, and my beam will be created. So these reference models can now be used to create real native COMOSYS objects, and then we can work with them. But the whole idea is that if we had imported them through the normal IFC import, then not only would they have automatically been converted to the local native objects, which we might not have wanted, but also then each one of those objects would need to be handled separately, because they wouldn't behave as a group. Whereas now, in this case, we can just go and say, just turn this one off, leave this one on, or turn this one back on and turn the other one off. So it makes the whole business of dealing or working with reference models a lot easier than the normal IFC import would have done. So we hope you like this feature. It's very useful. What we can also do is, as I had mentioned at the beginning, we can also import DXF models. Obviously, that's not going to be used a lot, but you can do that. And the one advantage which you will have over there is that if you import a DXF model, then any layers you have in the original DXF file will be available for you for showing and hiding once they have been imported inside COMOSYS. One small thing which I want to mention is the improvements in the filters. Now, previously, some filters related to plates were not part of the filter option, but they were, that capability was accessed from other parts of COMOSYS. But now what we have done is we have included under the standard filter the ability to filter according to the material of the plate and according to the part and assembly position numbers, prefixes, actual numbers, etc., and also the ability to filter according to the thicknesses of plates. So these were in the previous versions not part of the standard filter, and therefore they couldn't be used, for example, in drawings, or it was difficult to use them even on the modeling side. But now we have them over here. So for example, this building is mostly 355, S355, the plate material. And if I were to, or first of all, let me just remove all the profiles. So we have now, at the moment, we're only seeing the plates. And let me then go into the filter and select the 355 plates. If I just select that and I say OK. Now, like I said, this building mostly uses this one. But if I want to see that if I've missed any, have I by mistake left some, so I can use this not option, which means show me any plates which are not 355. And if I do that, then certain plates come up, and I can double click on them and see that yes, the material has been forgotten as some other material, and I can either make the necessary changes or leave it at that. Similarly, you can also now filter under the plates section. You can also, let me just remove this filter, and now I want to show you this thickness related filter. So you can filter according to the thicknesses. So you can say, show me the plates which have a thickness of greater than 5 millimeters, for example, and you can put an and or between them, and less than, for example, less than or equal to 10. So you have these operators of equal to or not equal to or less than, you can use all of them in combination with the first parameter and the second parameter. So now it's going to show me only the plates which are between 5 and 10, and if the thickness in millimeters. And if I were to say OK, then it filters out those plates, and I can just zoom in and double click on any plate and see that the thickness is actually, for example, this case is 10. This one is 10 as well. Maybe if I go zoom in a bit, maybe this one will be, this one is 10 as well. But if I were to then go into the filter and change it to between, say, not, which means show me the plates which are other than these, either less than 5 or greater than 10. And if I were to do that, then now I get these other plates. For example, this one is 20 millimeters, etc. So this is a very quick way of using the filter command, where previously we didn't have these options of filtering the plates in this way, and I think they're very useful for somebody who's modeling. Next, I want to talk about the on-screen editing handles. Now, as you know, COMOSYS has very powerful features for modeling, and one of them is the on-screen editing. And up till this version, we had on-screen editing mainly for the plate object and the rebar object, and they were both very advanced. And you could pick the handles, you could give chamfers, you could move them, you could delete the chamfers, you could move them to a surface. There are very nice examples of how these are extremely useful. Similarly, for the rebar, you could move the range, you could limit the range, you could make from a linear to a trapezoidal to a circular. You could insert points in between, you could move the points of the rebar definition, etc. So these are very useful as on-screen editing handles. But what we didn't have was, for example, for frames. So in this version, we have introduced on-screen editing handles for profiles as well. So just like for the other objects, we would just select the object and the on-screen editing handles would appear. Similarly, in this one as well, when we select the frame object, immediately, first of all, it shows you the length of the object on the screen. And secondly, it gives you these two handles, one at the start and one at the end. And you can just select that handle. And when you do that, you can either give it a direct move. So I can just say move it 500, for example, something like this. Or, for instance, I could once again select the handle over there. And instead of giving it a normal move in which I have to enter coordinates or distances, I can just say move the definition point to a surface. Press this button. And I can even give it an offset. Let's keep it 0 at the moment. But it's asking me to select a surface. And when I do that, I can just select a surface on the screen. When I do that, then this one is taken perpendicular to that point. This is basically a perpendicular extension of that point to the surface. You can always turn these handles on and off if you don't want to see them on. For example, right now, if I select any object, then the handles are turned on. But if I were to click on this button over here and toggle it, then the handles are not shown. So if you don't want to see them all the time, you only want to see them when you're using them, then you can turn them off. And if you turn them on, then they will appear on the screen. Another object which previously did not have on-screen editing handles is the folded plate. Now, previously, if we needed to modify or give chamfers to the folded plate, we needed to double-click on the object and then go to the chamfer tab, and then remember which point. For example, if when we were creating this plate, if this was the first point, the second point, the third, and the fourth, we needed to remember that if you want to give a chamfer to this one, then this is the second point. So we would need to do something like this. We would need to enter 2, which meant the second point, and then give the chamfer parameters, something like this, for example, and then we would get our desired chamfer. And now in this version, we have just given direct on-screen editing. So you see the handles appear now, which previously did not. And you can just go and select that chamfer for the second point and just say that I want to give this a chamfer, this type, and you just give those parameters. So you don't need to remember which point was which made it a bit difficult. You can just go like that. Similarly, you can go and then select the other chamfer, enter that, give it another chamfer variable, for example, and it's much more easier like this on the screen. Let's just undo that. And similarly, you can also select those chamfer points and just move them directly. Like I said, you can move them like that in the X direction or the Y direction or the Z direction. Or if you wanted to, you could select a surface on the screen and those points, just like I showed you on for the frame element as well. This is a very useful feature where you can extend that point to another surface, which you can select on the screen. Now, similar to the frame and the folded plate, which we just talked about, some of the parametric cut objects, which are very useful in modeling, some of these have also been given handles or on-screen editing capabilities. So, for example, the box cut has been given this capability in addition to the tapered cut as well. And these can be very useful if you want to create a parametric cut and then later move it around by using the handle. So, for instance, let's use the box cut. Let's use that. It asks for a surface. Let me select the top surface of this beam. And then it asks for an origin point. So let me just give it this one and just right click. Just want to create a simple cut so that you can see it on the screen. And I'll just get out of the command. And now that I've created it, as you can see, this cut itself has got certain handles on the screen. So for example, if I select this one and I can move it around by saying I want to give it an extension of about 50, it's going to move it in that direction, 50 millimeters, the length like that. Similarly, this direction also can be modified using these handles which I've just showed you. Similarly, if I was to use the cylindrical cut, for example, as a parametric cut, I can once again show the top surface and then show a point and just create a default cylindrical cut. And then if I select the cut itself, you can see that I have these handles for adjusting the length of the cut and the radius of the cut. So for example, if I were to choose this handle, I can just go in and modify the radius of that cut by moving it 50 millimeters in that direction. Similarly, I could choose this particular handle and I could increase the length of the cylindrical cut. So in this way, it's very easy to use these parametric cuts and then use the handles for on-screen editing. Another very important parametric cut, which can be used for on-screen editing, is the tapered cut. Let me just try and use that. So let me select this side, the side of the flange, and then I can create that cut over here by, say, for example, if I use this point, and then I just give it a, let me just give it a DX 500 point. That's quite far, but anyway, then I can stick at this point and say something else. I can say at 500, comma 0, comma minus, say 200 or something like that. Yeah, and then I can stick at this point and say DZ minus 200. So this feature is very useful. I can now select the last point again, and then it asks for creating creating holes inside this cut, which I don't want. So I'll just right click, and it creates that cut immediately over here. Obviously, it's not penetrating the object at the moment, so I just need to maybe move it a bit. I can move it linear in the Y direction, say 100 millimeters. And now it's cutting the object. But it's like a polygon cut. You can use as many points as you want. But now what I have a feature over here is the definition points which I use to create this polygon cut are available as handles. And I can even insert new points in this cut. Just like you can insert new points in plates, you can insert new points in this cut. So if I were to select this point, for example, I can give it a chamfer, for example. I can give it a chamfer of type this one and give it a radius of, say, 20 and say apply. And immediately I get a little chamfer over there. So just like I showed you that by selecting this tapered cut, you could give chamfers to points. You could also move the entire definition lines. So I can take this entire line, for example, and say move it downwards by 50 millimeters. Or what I could do is I could just maybe select this point only, this point doesn't exist, it's the midpoint, and I can create a new definition point by adding a new vertex to this cut. So just imagine that I've modified the whole definition of the cut on screen, and let me just move that a bit more now. Now it's a new point, so it's a lot easier now. I can do that. And if I remove the cuts from the screen, you can see how I have cut my object. So this is extremely useful because after creating the cut through the tapered cut command, you still have the definition points on the screen, and you have the handles on the screen. You can give chamfers to the corners. You can insert new points in the cut. You can move entire lines. So this line, for example, if you wanted to move it to the right, all you needed to do was, for example, reset this and say move it 100 in the X direction, and it will go 100 in the X direction. So this is very useful. And this on-screen editing for cuts, the availability of on-screen editing for cuts as well, will really make the job of the detailer a lot easier, we believe. Now let's talk about gratings and checkered plates. Now, previously in COMOSYS, we could model gratings and checkered plates, but there was no way of distinguishing between them easily visually on the modeling side. On the drawing side, we would have these symbols to represent them, and from then we could, from these symbols, we could tell. But on the modeling side, we did not have these symbols, so it was difficult to tell what we had modeled unless we double-clicked and checked the usage. But in this new version, what we have done is we have created this ability to create these symbols. So for example, this is a checkered plate. And now we have the ability, the moment we select the checkered plate, it automatically draws the symbol of the checkered plate on the model. Now, Now, what it can also do is you can decide whether you want to see that symbol or not. So if you remove this tick, then the symbol also disappears. But if you put it back, then like I said, you have the option of seeing it. Now, another option which you have is you can give certain offsets. So for example, if I were to give an X offset of 1500 millimeters, I can shift that symbol a bit to the left or the right or the top in whichever X or Y direction I want, because sometimes the reason why we do so, it's not that important on the modeling side, but wherever we place this symbol on the modeling side, it's going to appear at the same spot in the drawings as well. So the user now has much more control over how the symbol will appear and where it will appear. So let me bring that back to its, or we can even give it a rotation if you want. Let me bring it back to the original one. This is the grating symbol, as you know, and this has also been now provided for the modeling side as well. Once again, we have whether we want to draw the symbol or not, but we can also choose whether we want to place it in the short direction or in the long direction. So if we want on the modeling side, we can show the direction in which the grating, how the grating will be designed. So the user now has more control over this grating symbol, which can then pass on this information to the fabricator as well. And not only that, as you can see over here, sometimes we have a very weird piece of grating and we want a particular direction. So then we can use the rotation angle to exactly define what the direction of the spanning beams of the grating would be. Similarly, we have these two new options. We did not have them at all. This is the diamond plate in the usage. It's all being done from the usage, by the way. The diamond plate option has been added. This wasn't there previously. And when we choose that, then we get this symbol by default. And similarly, when this fourth one has been added, which is for expanded metals, expanded sheet, this one gives us this particular symbol. Now, these symbols are the most commonly used symbols globally. But if you want, you can. We will be talking about something called the symbol editor in this webinar later on. And in the symbol editor, we will show you how you can actually create your own symbols. And if you do that, then you can actually link those symbols to these plates as well. And how you do that, I mean, I won't be showing that at the moment, but you basically go to project preferences. And if you go to the symbols over here, it shows that for the checkered plate and for the grating and for expanded plate and for the diamond plates, you can assign 4 different symbols from a particular symbols file. I mean, we haven't talked about this, so I don't expect you to understand how the details work. But basically, you will create your own 4 symbols. You can assign those indices, and then whatever symbols those are, whatever symbols you use in your country, those symbols will appear on the modeling side. And of course, the same is true for the drawing side as well. When you decide on these symbols, when they go to the drawings, then on the drawings also you will get to see the same symbol. So this is a very important improvement which was lacking in COMOSYS. This ability to customize all these symbols for grating and checkered plate and adding your own symbols, etc. And this is something which we have added to the new version. Now, the next thing which I want to talk about is once again related to what I said in the beginning, that we are pushing for better features when it comes to customizability. And one of such features is the ability to create arbitrary symbols of any sort, like the ones you see on the screen right now. And then use these symbols anywhere in the drawings, either directly or as a part of some text, or even as part of customizable annotations. Now, this is a world where, I mean, this is almost impossible to provide as an off-the-shelf solution, in the sense that everybody uses different symbols for different things. COMOSYS, being a general-purpose program, allows you to model just about anything you want under the sun. So it's literally impossible for us to provide all the symbols which everybody could possibly use. So what we have come up with is what we call the symbol editor. which allows you to create your own company symbols, as many as you want, in as many groups as you want, and then use these symbols once again in your drawings. So now I'm going to show you about the tool that we have developed in this regard. Now, if you come to the drawing side of COMOSYS, not the modeling side, but the drawing side, where we have all the commands for creating drawings, under the Tools menu on the right, we have something new, which we did not have before. It's called the Symbol Editor. And if you were to click on this, a standalone application opens up. And I'm emphasizing that this is a standalone application which you can use from within COMOSYS, or you can distribute it and people can create their own symbols and send them back to you. It's a standalone exe, which can be used separately from COMOSYS as well. Now, what happens over here is that when you open it, it gives you a clean file with one empty symbol inside it. On the left-hand side, you will see the symbols appearing like this. And then so for example, there's only one at the moment. And I can start drawing inside this boundary area provided. And I've got lots of commands at the top. If you see, I can create a line. For example, I can just go from here to here, and I can create a line. I can create a circular arc, elliptical arc. If I want, I can create a rectangle. So for example, I can do something like this. I can create a circle if I want. I can go like that, and these are basically snappable points you're seeing, and you can modify the grid spacing. You can make them more dense and more precise if you want. You can create continuous lines. So, for example, I could start from here like that. Basically, it allows me to do what I want, and I can right-click to finish the command. Then it can allows me to draw polygons, ellipses. It even allows me to write text. So I can just click over there and write a little text over there if I want. And then it allows me to rotate these symbols. So I can select these symbols. I can choose the select command. I can select this rectangle, for example, and I can double click on it. And I have got access to, I can make its line thickness maybe more than the other ones. I can change that number to something which I want. I can change the color. For example, I can give it a different color. I can change the line type from solid to dash to dot, dash, dash, dot, whatever. I can, if it's a closed shape, then I can decide where it is filled or not. So let's choose one like that. Let's take the circle, for example, and see that the fill type is solid. And in that case, we get a solidly filled circle. And we can, basically go around creating arcs and lines and polylines and circles and rectangles, giving them line thicknesses and all. And as you can see, it's being recreated on the left-hand side. And once we are done with finalizing this symbol, we can add another symbol to this file. This is basically showing you one file, and any file can have as many symbols as you want. Once you're okay with it, you can say add, and it gives you another empty symbol, and you can say add and it'll give you another, and you can keep drawing inside. The one you select is the one you're going to modify on the screen. And using these commands over here, you will be able to let's see, you can fit it into the frame, you can zoom in, there are some snap options, you can show the grid or not show the grid. There are settings for the text. So if I press that, you can select the text font, the font size, font style, the font itself, etc. Similarly, there are general settings regarding the line thicknesses and for the next object that you're going to create, basically. But it has a lot of flexibility. And once you're okay with all of that, you can just press this save button, and this is going to save the file. There'll be a symbol file, which you can then save away anywhere that you want. It can be in the company directory, company folder, or in the model folder, and there are some details to that which I won't get into. But you can distribute these files to other people in the company, and they can then, and you can make multiple files of this sort as well. So it's a very handy feature. And once you are done with this, like I said, it's almost impossible to provide all the symbols which you might need. So for example, let me just load a symbol file from here. Let's see. Let's go into another directory, program files. Sorry, that would be program data, Proya software, COMOSYS 2024 preferences. This is where the company files will be stored. And come down, there's a symbols directory. And inside there are many files already there. So for example, if I were to double click on this one, you see that it already has many different symbols created inside it, which you can use depending on your requirements anywhere you want in the project. Let's go back, and there's another one called miscellaneous symbols. So you can have your rail symbols, your cladding symbols, some other, maybe your north symbol, some pipe related symbol. You can, like I said, you can group them and you can create as many as you want. Plate symbols, so these are your, for example, checkered plate or grating or expanded sheet metal symbols, etc. So you get the idea. So these are profile symbols, these are filled profile symbols. The idea being that you can create as many files as you want, you can store them away, and then you can use them in the drawings exactly the way you want. Now, obviously, the next question coming to your mind would be that how do I use these symbols? And as I said earlier as well, there are three ways you can use them. The first and the most obvious one is you can directly insert these symbols anywhere you want on your drawings, just by clicking on a point, and then that symbol will be inserted at that point. That's the most obvious usage. The second usage is that you can make them part of a text. You can have a text around it. It could be a multi-line text, a single line text. You can put it inside somewhere in the middle of the text. And the third usage is that you could use as part of custom annotations as well. So you could have a very complicated annotation in which you write certain fields and then you insert a symbol and then you continue writing something. It could be a complicated annotation, but you could use these symbols inside annotations as well. I'm going to show you at the moment how to create these symbols directly on the drawings and then also as parts of text. But when it comes to using them as parts of custom annotations, I will show them when we get to custom annotations. So to create them as part directly on the drawing, if you go to the edit menu, then under there's this command over here, and under it we have two options: create a symbol and create a symbol along a line. This is basically just to put a symbol on the drawing directly where you want. The difference between this command and this command is that this one asks for just 1 point and this one asks for 2 points. It allows you to orient the symbol. So for example, let's use this one. It's going to ask for 2 points. I'm going to go in there and I'm going to select 1 point, and I'm going to, the moment I start selecting the other point, it creates the default symbol, and I'm going to just leave it like that. It's created a default symbol, and now I can double click on this. And when I do that, it shows me the file name from which it has brought the symbol. If you remember, we were just talking about the symbol editor. You can save away as many files as you want in the company settings or local model directory. So let's go in there, and you can, so let's change it to the build, or let's change it to miscellaneous, this one maybe, and see what we have in there. Okay, we have this north symbol. We can use that. And when we do that, we see that we have placed this north symbol inside the drawing. It's been aligned in that direction. Now, once it has been inserted, you can change the size as well. By default, all symbols are created with a size of 10 millimeters on paper. So the default size is a paper is based on millimeters on paper, and that'll be the default size. But if you want, you can make it bigger like that, and then you can shift it somewhere else. Or what you could do is you could change the rotation. In this case, we already gave it a certain direction, so it's calculated that degree. I can change it back to 0. It's going to point directly upwards, and I can give it a different angle, etc. But what I want to show basically is how easy it is to create these symbols and then use them directly on the drawings. The other way which I mentioned was creating these symbols as parts of text. So for example, if I were to create a simple horizontal text with a leader, let's just place it like that. And then, for example, we could leave it over here. This is an empty text right now. I can double click on that. Let's say if I start writing, this is the symbol. After writing this much text, I want to actually insert the symbol over there. So you see this little button over here. If I press that, it's going to take me to that same file name and index. I can go in there and I can choose my built up sections, for example, and I can go into to find the index. Let's go and choose this one, for example. And this is the symbol shape. So I can write some text around it as well. And when I do that, then you can see on the screen that symbol has been inserted inside that text. And in this case, the size of the symbol will be the same as the font size that you're using in the text. So if you increase the font size, the size of the symbol is going to change according to that. Basically, any text you create, it could be a vertical text with leader, or horizontal text with leader. It could be a multi-line text or a single-line text. Any text you create, you can insert these symbols inside the text, not just once, but you can insert them multiple times as well. So it's a very useful feature. Like I said, you can use these symbols directly. You can use these symbols as parts of text, and you can also use these symbols as parts of complex custom annotations, which we will talk about when we get to that topic. One last thing I would like to mention is that, as I said in the beginning, there's a boundary over here inside which you need to create your symbol, but it does not stop you from creating a symbol which goes outside this boundary, as you're seeing on your screen right now. It'll basically just take the whole thing and draw it when you actually insert it in your file. The central box will only be used for locating the origins of the symbol. So you could have a long rectangle if you wanted to, a vertical one or a horizontal one or some other shape. It doesn't necessarily have to stay within the boundaries of the square which is provided. So that makes it a bit more useful, because sometimes we have these legends in which you have these long rectangles which are used to show different types of symbols inside them. And even in those cases, you can use the symbol editor to create those symbols. Now, let's move on to another very important topic, which is custom annotations. As you know, that annotations are the heart of all drawings, and all different objects like profiles and plates and bolts, etc., and generic solids are all annotated in COMOSYS. And that is really the heart of drawing creation, because you create objects and then you annotate them with the fields available for those objects. Now, we had, if you remember, we had annotations before. We have annotations before. And these are whatever fields we provide to you off the shelf, and you can basically add these fields inside and create your annotation. It's pretty versatile. But with this version, we are actually improving this a lot, and we are giving you the option of creating your own custom annotations. And this really revolutionizes this whole area, because once again, like I said in the beginning, that in this version we are focusing on customizability, because everybody does things their own way. So we'll be talking about custom annotations, and I'll be explaining to you how we do that. Now, to create custom annotations, just like I showed you under the tools menu, we have the symbol editor. We also have now what we call the custom annotation catalog. This is basically the place where you create all your annotations or your custom annotations. And this is the place where you create custom annotations for profiles, custom annotations for bolts, custom annotations for solids or for plates or for rebar or for anything, basically. So we'll be talking about this particular command in detail. And what you do is you begin by clicking on this. And when you do so, it will open up whatever existing custom annotations you have created up till that point, and it shows you a list of those annotations. So, I mean, this is a sample which comes with the setup. So sample rebar annotation, three sample rebar annotations, 2 sample profile annotations, a few plate annotations, etc. So you can actually look at them and then see how they work. And it gives you this list in the beginning, so you can choose any one of them and then modify them and save them as a new one if you want to. Now let's begin by creating our own custom annotations. So these are the existing ones. We don't want to do anything with them. Let's just close this. And after we've closed this, if we go over here, this little button with the plus sign, it says create a new custom annotation template. These will all be, any new custom annotation you will create will be called a custom annotation template. So you press this button, and when you do that, this little dialog box appears. And here you can give your custom annotation a name. So for example, I will give it a name called my profile annotation. Right? You can give it any name you want. This is the name which you will then use later on to recall it to create the annotations. Now, I've called it my profile annotation. It asks for a category. Now, the category can be any one of the object types. Because I'm creating a profile annotation at this point, if I open it, you see I can choose it to be a profile or a plate or a bolt or a weld or a rebar or a formwork or some solids. Because it's a profile, I just use the profile one. If it's a profile one, then the subcategory field is not required. It's required if it's in the case of generic solids. And it gives me an initial number of rows, which basically tells me that this custom annotation will be 1 row. Now I can change that later on as well. So I'm okay with that. And I just say create. And when I do that, it creates a sample annotation, which I can then modify whichever way I want. Now, if you see, it has provided us with a sample annotation. And like I said, we can modify it. So let's look at it a bit closely. What we see is that there is the name of the profile over here. So this is a field. What I mean by a field is that this will depend on what profile you're annotating. It will look at the profile and it will annotate according to that particular profile. And you can select this field. The moment if I select it, on the left-hand side, let me open this up a bit and let me maximize this so they can see easier. When I click on somewhere over here, then these fields disappear because nothing is selected. All it's saying is that this entire annotation is called my profile annotation. It is of the category of profile. Let's not worry about the anchor row index at the moment. But when the moment I select a field from within this, this whole area changes. And now it's giving me information about this particular field, HEA 300, which is basically the name of the profile. It's saying that this field will automatically take the data intelligently from the profile name field of profile objects. Now, as it is selected, if you see over here, it says profile name. It gives you the sample text. It also gives me a left padding and a right padding. If I say a left padding of 2, you can see that it's given a left padding of about 2 spaces at the left. So maybe I want this annotation to have some empty space in the beginning. Or if I can maybe want 3 empty spaces at the end. It's showing you as you create it how it will actually appear on the drawings. There'll be an empty space in the beginning, which is the left padding. There will be an empty space after it, which is you can change these numbers, like I said, whatever numbers you want. And there'll be a padding after that. And then there will be another, this is another component of this annotation. This is the first component, which is a field, profile name. This one is just a text, it's telling me. You can add 4 different types of things in a custom annotation. You can add fields, you can add user-defined attributes, which is also new. I mentioned those while I was explaining user-defined attributes, that whatever user-defined attributes you create can then be used as parts of annotations as well. The third thing which you can put in a custom annotation is just pure hard-coded text. So sometimes, for example, you have brackets or some other things which you want to put. you want to write something down. In that case, you will insert a text. And then this S355 is another field which says object material over here, if you see on the left. And then there is another text. So this basically, this little custom annotation at the moment, it consists of 4 components: a field, a hard-coded text, another field, and a hard-coded text. If I want, I can select any one of these components, I'm selecting this field over here. And if I press the right arrow key, I can move it to the right. And if I press the left arrow key, I can move it to the left. So any component, I can select this bracket, for example, and move it to the left, move it to the right, or move it to the right over there, move it back. So all these individual components in that line can be moved left or right by using the left or right arrows. I can give a right padding to this bracket as well. For example, if I give it a right padding of 2, and that bracket now has a right padding of 2, and then the material name will be written, and then the closing bracket will come. Let's bring that back to 0. So this is, as you can see in this line, in this custom annotation line, I've got 4 components: a field, a hard-coded text, another field, another hard-coded text. What else could I have had? I could have had a user-defined component, a user-defined attribute as well. And I could have had a custom symbol as well, but we'll talk about those later. So this up to this point, you're seeing that I can actually take all these components and move them around within that line. What I can also do is select any one of them, and I can change the text height, for example. So I can make this one 5. As you can see, this is a bigger font now, whereas the other one has a smaller font. But maybe I want to align, now they're both in the middle, but I want this right hand side to be aligned with the bottom, so I can select this bracket, and instead of the vertical alignment being center, I can say bottom. And similarly, I do the same for this one, and the same for this one. And now I've got 2 different font sizes, and the alignments have also been designed according to my liking. Now you can see that if I select, for example, this first field and the first component of this line, you can see from the left-hand side, I showed you the left padding and the right padding, and the vertical alignments and the font heights, etc. But you can do other stuff as well, like you can change the color of the font to maybe something else. What you can do is you can put a rectangle around that particular component. Or you can add a circle around it, or a rounding rectangle around something like this, which is rounded. That's up to you. What you could also do is you could change the color of that rectangle. You could even have a brush style, which could be like a cross, something like that. It's like a fill. So, or you could maybe, let me change instead of a cross, if I make it solid, then that basically fills the whole area up. So I've got certain options over here. Let me bring that back to clear, and this to none, and this back to the black default. So you can play around with each component, give it a different font size, a color, a background, something around it, etc. And this gives you a lot of flexibility. You can put padding on the left, padding on the right, and stuff like that. But what's even more powerful is that this custom annotation doesn't need to be limited to one line. What you can also do is add another line to it. So how do I add another row to this? What you can do is, while you're selecting any component, you can just go to the left-hand side over here, where it says add new field, remove field. You can say add new row, and it also has a remove row next to it. So let's just say add new row, and immediately a new row is added over there. And I can select that, and I can say move row down. Okay, I need to press right now, as you can see, I have selected the component within that row. It's not very clear maybe on the video, but it's the component. To select the full row, I need to press escape, which takes me 1 level higher. When I'm at that level of the full row, I can move this row down or up wherever I want it, basically. Now, one thing which I can do is I can select this field over here in the component in the second line, and then I can press escape to basically select the entire line. I just press escape. I thereby select the entire line. This represents the full line now. And then I get this horizontal alignment. So I can press center, and now this whole thing, whatever I have inside this entire line, will be centered along the entire annotation. I can press right if I want. That'll be like that. Or I can bring it to the left once again. If I go inside the field, then once again, I have my left padding. I can put a padding of 4 spaces in the beginning, or I can put a padding of 4 spacing at the right. It can be a text, like I said. It can be other things besides a text. If I want, I can choose another field. For example, I can say, give me the object, for example, part actual number. So if I want the actual number, it's going to give me an actual number like that. If I wanted to put a P behind that, then I could have first added a text and then put the part actual number. And I could have put a space in between them. Basically, I could have constructed my part number in whatever way I wanted, unlike previously where you would be limited to whatever options COMOSYS was offering you. And in this case, you can write a big P in the beginning, put a dash, put a small 27 in a different color. Basically, you can create your own entire annotation. Now, over here, because there are 2 lines, one thing which we need to know is that up to 3 lines are supported. So in these custom annotations, you can have 3 lines. And in between the lines also, if you want, you can have spaces. So what you do is, this little thing basically represents, so if I select this one over here, and I press escape, it gives me a top padding and a bottom padding. If I give it a top padding of 3, I can put a space between the lines as well. And if I put a bottom padding of 2, it gives me a space after that line as well. And if I were to, if I wanted to, this is the anchor point. This little round circle you're seeing over here is the anchor point. So sometimes these fields are used with text leaders in annotations, and you want the text leader to go in between these 2 lines. You want a line in the middle, something written on top, then the text leader line, and then something in the bottom. So in that case, you can create this little gap over there. But you also want this anchor to be over here in the middle, because that's where you want the line to pass from. So if you want to take this anchor in the middle, then what you do is basically you come to this general area which represents the entire thing, and there's something called the anchor row index. If you change that to 1, it'll move. It could be 0, 1, or 2 depending on how many lines you have. 0 means like the bottom, and then 1, and then 2 maximum. So if I give it a 1, then the anchor point will become the center, and then we have a little gap in between them. So these little tricks allow you to create all sorts of combinations you want with your custom annotation. Now, if you remember, I had said that you could even use your custom created symbols inside these custom annotations. We just talked about creating custom symbols, and you can create any symbol under the sun. You can create a library of symbols, and then and those symbols are stored in files, if you remember, and within each file they have an index number. So over here now, if I want, so I've written let's say the part position number. And I want to add a symbol after that, or a symbol before that, doesn't matter. So if I come over here and I say add new field, if you see over there, if I add a new field, it gives me a new field over there. Now, if I select that, it's by default, it's a text field. But if I open this up and I go all the way down, you see all the way at the bottom, there's something called a symbol. And when I do that, it gives me the option of writing a symbol file name over here and the file index. And when I do that, then whatever symbol resides at that index of that file will appear next to it. I can give it a size. This one, I can give it a size of more than whatever the size is. I can make it bigger or smaller. So as you can see, this custom annotation is extremely powerful. It allows me to create up to 3 lines. Each line can have as many components as I want. Each component can either be an intelligent field, it could be a text, it could be a symbol, or it could even be a user-defined attribute. So for example, instead of the symbol, if we come down over here, there's a user-defined attribute over there as well. And in that case, you give the UDA name, which we discussed in the beginning. And whatever UDA name you give, if this object has that, it will create that when creating the annotation. So it's a very powerful new technique. You can create these totally customized annotations. You can save them away. And when you save them away, they will appear in the annotations command. That's how you will use them. So the first thing you do is you create these annotations, save them in this file. You can be happy with how they look. You can change the font size and this and that. And once you're happy and they're exactly the way you want them to be, then you save them in the file, and then you go ahead and you use them with your normal, the way you use your normal annotations. And I'll just show you how you do that. Now, the next question obviously is that now that we have created these custom annotations, how do we actually use them? So you do know how to use the old annotations, which are the built-in annotations or off-the-shelf annotations. They're over here, if you remember. And you go to the annotation settings, where you select the built-in annotations. You basically press the same button again. This is what it used to look like. This is what it still looks like. But now we have at the top built-in annotations, which is what we had before, and we also have this custom annotations. This is with regards to profiles. Obviously, there's the same thing with plates and with bolts and with solids, etc., and with rebars. So if you want to use the existing off-the-shelf ones, you can just do so by dragging in. So you can, for example, say I want the profile name and I want the material name, etc. But if you don't want to do that, if you want to use the custom annotations, then you clear them, you leave these empty, and you go to the custom annotations place. And now when you do that, you see you've got two new custom annotations which are used for profiles. You can, of course, go back to the file and add as many as you want. No, so let's basically take this and add this over here. So this is the sample profile custom annotation. It basically gives some assembly part number or something like that, and you apply it. And how do you use it? You basically this one already has the existing annotation. So I'm just going to select this frame, and I'm going to say annotate the selected profiles. And now it has annotated it with the new one. This new one was basically what I just showed you. It's a custom based. You probably made a bracket, then you wrote a P, and then you basically put a this dividing sign, then the number, and then the bracket again, and the second line material. You could have made different sizes, different colors, whatever you want. So using this technique, basically that's all you do. You don't need to learn anything new. You just go to the custom annotations, you choose the annotation you want, and you basically select your profiles and you apply the annotation. It's as simple as that. Now, you might be wondering that only two custom annotations appeared under the profiles annotations, whereas I had shown you a lot in the custom annotation editor. So I've put it back on so you can see them again. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 custom annotations. The reason why only two of them showed up over there was because only two of them had the category of profile, this one and this one. The first three were for rebars, and the last six are all for plates. And we can see, so these KM plate option 1, plate option 2, 6 different types of annotations for plates. If I close this editor and I go to my annotation section again, I had showed you the profiles over here. There were custom annotations two of them. But if I were to show you the plates section, in the custom annotation, you can see the 6 custom annotations with the name starting with KM. And similarly, if I go to the rebar annotations, over there we can find the 3 sample rebar annotation custom annotations which we had developed. So you can create as many custom annotations as you want. You just provide a category for them, whether they belong to profiles or plates or bolts or rebars, etc., or generic solids, etc. And once you're done using them, then automatically the program will categorize them and they will appear under the proper headings. Now, the next thing which I want to talk about is also very important and also has to do with our central theme this time, which is customizability. Now, what I want to talk about now is custom tables, custom table managers. Now, if you remember previously, one of the most important parts of such programs is the creation of drawings and the creation of reports, basically extracting information from the model. And in the creation of drawings, you have material lists. You know, it could be a part list or an assembly list or a bolt list or a weld list or a rebar report or anything of that sort. Or you could just take a material takeoff in a normal report or something. And previously, this was all managed obviously through the layout manager, but it was all managed through predefined tables, which you could add to your drawing, for example. And these tables had some level of customizability in the sense that you could change the fonts and the width of the columns, and you could maybe do some minor modifications, but more generally they were like hard-coded built-in tables. Obviously, these are the ones which are used most often, so they do get your job done. But what we wanted to develop was something which the user could then use to create their own tables. Totally, like where they would have all the fields available and where they could create and define their own tables, and therefore once again allow them to work with any kind of client in any kind of project where they have specific requirements for these tables and these reports. Now, to do this, what we have done is we have developed something called the table template editor and manager. And to access it, you need to go to the drawings and reports menu, and under it, there's the material takeoff button. And if you open that, then towards the end, there's the table template manager. This is the tool which you will use to now create your own tables, your own reports, which you will then be able to use in the drawings or just directly. So if I click on this, what it does is it opens up this entire template template editor. Now I will give a brief summary of the capabilities of this new tool that we have developed. The first thing which I want to focus on is over here in the top left, which is the table type. And this basically means what kind of objects will be included in this table. So the options you have at the moment are plates and profiles. So typically, for example, if you have your assembly drawings and you have material lists of assemblies, so each assembly can have both plates and profiles inside them. Imagine it being with lots of plates welded to them, and you're trying to create the material list of that assembly. So that would be something which contains both plates and profiles. It could be a table which only contains profiles or only plates or only bolts. So imagine a bolt list, a bolt table you want to create, or a weld table or a rebar table. So these are the options you have at the moment in this version, and you can choose according to what type of table you want to create. The next option is the filtering option. Now, as you know, these material lists are generated. If it's in a drawing, for example, then all the parts which are shown on the drawing will be included in the material list. So you may not want that. You may want to filter whatever objects are available on the drawing. You might want to have a further filter on those. So you can use filter settings, which will further restrict whatever is in the drawing. If you're using this as a report generator, then once again you might need filters because you might not want to create tables or reports for the entire model, but for only certain part of the model. And you can use the filter, or you could use a selection-based filter. So you can directly select some things on the screen and create your report or your table accordingly. The next thing which I want to talk about is the availability of these fields, which you see over here. Now, we've chosen a plates and profiles table. So all the fields which are available for plates and profiles will be listed over here. And if I were to scroll down, you will see that at the end, you also have user-defined attributes. And that will depend whether we have user-defined attributes in the particular model that you're working with, etc. So you can not only use the built-in fields, but you can also use the user-defined fields in your tables, which we will also see the results of in a minute. But this is what I want you to know, that on the left-hand side, we have these fields which we can use. On the right hand side are the fields that we have actually used. So this is the list of all the fields available, and this is basically the fields which we want to have in the table. Now this is when you open this up, it basically gives you a few fields ready to use. But if you want, you can just clean up the slate on the right hand side by pressing this button, this delete button, and it will remove all the existing columns basically in the table, or all the fields in the table basically. And then you can add, for example, if you want the name field to be in there, you can say plus. If you want the part mark, you can say plus. If you want the covered area of that part, you can say plus. If you want the unit weight, you can say plus. If you want to say the gross weight, for example, you can say plus. And this way you basically create all. And if you wanted, for example, to include this particular user-defined attribute, you can say plus again. And by doing it this way, you can put all the fields inside, and then by using the arrows, you can move these fields up and down. So maybe after the name, you want the user-defined attribute, and in this way, you can create the exact content which you want. Now, these fields which we have available on the left can be of several types. So obviously, they can be a text-based field, which means it's basically a text. It could be an integer. So for example, the count, how many parts do we have in this assembly? So maybe 12 plates or something. So it could be an integer, or it could be a decimal number, like the surface area or the weight, for example. But it could, like I said, it could also be user-defined attributes, but then it could also be symbols. So the symbols, for example, if this is a rebar table, then the rebar sketches, the shape codes, etc. Those so basically the physical shapes can also be put inside these inside these tables as fields. So for example, if I were to select the rebar table, then if you go to the available fields, you have shape codes over there, and the shape symbols are automatically appear as well. So you have the ability to basically put your text fields, your integer fields, your decimal fields, but also user-defined attributes, as well as sketches of certain things or custom symbols inside these tables as well. Now let's go over these options which we have one by one. So for each field, we have a caption, which means that for each field, obviously the field has its internal names, but you can change that name and you can give it a new caption. You can change the language of this. You can basically write anything you want, and that will appear as the caption of this field. The next two fields are the length and force units of the particular field, if they apply. So for example, if it's a name, then obviously you don't have length and force units. But if it's a length, then certain length units apply. And if it's a force, then if it's a weight, for example, then the force units can apply, as you see on the screen. And these two units can also be available for the user-defined attributes. In this particular case, the user-defined attribute we're using is a text, so they don't apply. But maybe you were entering a cost, for example, which needed to be then added. So it could be a number, or maybe you were, something which needs to be added. Those kinds of things. So you can have certain user-defined fields which have their own units, and maybe the user has entered them in centimeters, for example, but in the report you want them to be reported as millimeters. So you can change the length and force units in the next two fields given over there. Then you have the option of showing these units or not. So you might report something in millimeters, but you won't necessarily write the word mm next to them, or you can choose to write it depending on what you want. After that, there's the precision and format, which you remember from the dimensioning tools which we have. You can choose the exact precision of that length field or force field. So you could decide to report it with a certain precision, and also the format. And these formats are exactly the same as the formats which we have on the other side. So you can use these formats, and then according to whatever format which you choose, your table will be created accordingly. Now, obviously, the purpose of these tables is to take totals, subtotals, and grand totals of fields like weight and area and length, etc. So you have these options over here of group by, add, and grand total, and these three in conjunction can be used to basically give you all the combinations that you want. So, for example, if you wanted to collect all parts of the same section name, all with having the same section name, you could say group by, and it would group by the section name, and then it would take it would add the net lengths of all those with the same section, or add the cover areas, add the net lengths, and also give you the grand totals. So basically, if whatever variables you want to group by, they will be brought together, and the totals and subtotals will be based according to this grouping. And after you've chosen the grouping option, you can choose whether you want to, and obviously you would want to add these kinds of fields. And if you want to take grand totals as well, you would then select these. So this will basically give you a very easy way to get to those kinds of results very easily. Now, you obviously have control over the exact column widths of these fields in drawings, as well as on the text report side. You can have control over alignment. You have things like use this table in Layout Manager. Obviously, if you want to create drawings, then you have to include this table in the Layout Manager. But sometimes you're just using it for other purposes, just for some temporary reports or something, so you can remove this if you want. You can choose to ignore reference models. So you might have your reference models appearing in the drawing as well, but you don't want the material list to show any material in the reference model. So you can, select this, that it's like an automatic filter. You could have done it through the filter settings, but it's like a overriding filter you have over here. You have control over text, etc. You have control over your row heights and caption row heights and item row heights. All these font variables are available over here. So you have a very powerful system of creating more or less any kind of report which you want. Now, once you're happy with what you've created, whatever fields you've put and all the parameters that you have set, you can save this, you can give it a name and save it away, and whatever, you can create hundreds of tables, and then you can use them later on in your drawings or in your reports. So let's, for example, if I were to open this, these are the ones which have already been saved away. You can choose any one. Let's choose the material list, for example, and you say load. And when you do that, it loads the material list table from whatever it is that you have defined. And now you can basically, like I said, use this in the layout manager. But I'm going to just show you how to preview this. So whatever you've done, you might want to preview it, what kind of results it's giving. So just press the preview table, and it'll show you a text preview of the table, which is this is not obviously exactly formatted the way it will appear on the drawing, but it's a quick preview to give you an idea of what kind of table it's producing. If you want, you could save it as a report, open it as a report, or save it as a CSV files. If you open it as a report, then it gives you a properly formatted report, and you can use this as a text file. You can copy it to clipboard and save it as a text file, or you could save it as a CSV file and open an Excel or something. Or you, like I said, you can you've already saved it, and you can use it in the layout manager. And obviously, I'll just now quickly show you that these tables which you have created, these custom templates which you've created, can also be used from the layout manager. And I'll just show you the results. For example, I have a few drawings. So if I would just open this drawing, you can see that this table has been created from the custom template editor. And over here, you have this user-defined field as well. So just to give you an idea, it's a very similar looking. It's one of the very commonly used tables, but this has not been used from the built-in off-the-shelf tables which we provide. You can basically create your own. You can use your own fonts. You can create your own column widths and all. You can include whatever fields you want. Like I said, you can even include shape codes and shape sketches if it's a rebar table. It could be, if it's a rebar material takeoff, you can use the shape sketches of the rebars, or like I said, you can use the user-defined attributes. So this is a very powerful new development, which we hope will solve the issues of many of our clients who have very specific requirements according to their countries. And by using this new table template editor, they will be able to provide any kind of table which their client requires of them. Now let's talk about some new macros. I know everybody likes to talk about macros because they really make our job a lot easier. So I'm sure you'll be excited with the new macros we've developed for you. I'll start with the steel detailing sector. And for the steel detailing sector this time around, we have 5 new macros for you. Yeah, that's not a small number. Usually with new versions, most programs will give like 1 extra macro or 2, but we've got 5 new macros for you. And I'm going to start with one very commonly used situation where it's very common to use the rectangular hollow sections in trusses, for example. And since all the profiles are rectangular hollow sections, situations like this are very, very common, where they sort of run into each other and they need to be cut and welded to the main profile. And maybe this one needs to be adjusted according to this one and that one, and they're basically fitted according to the main profiles. So for this situation, we already had a welded pipe macro, but it worked for pipes primarily. But some of our customers wanted us to develop a welded box macro. So we've done that, and it's extremely simple to use. All you do is you select the main one, you select the secondaries in whatever order you want. And after you've selected all of them, you just right click, and that's it. Immediately, the cutting and the fitting and the welding and everything has been accomplished. Another situation which is very common in steel detailing is when you have a column which is larger in size, and at the next story level or whatever level you decide to have the splice, the column which is continuing is of a smaller size, and not just of a slightly smaller size, but of a significantly smaller size. And that really makes using the classical splices, where you can use a few filler plates of maybe a few millimeters thickness to cover for the changing height, very difficult, because the change in the size of the two sections is significant. And other methods can be used to connect. And for what we've done in this version is that we have provided one such solution for you, which is very useful, very handy. And all you need, it's called the reduced section splice, where the reduction is very significant. All you need to do is just click on it, select the bottom column, select the top column, and immediately you have this connection made for you. I'll just go into it, pressing, as you know, M, then enter, and load my company defaults for these two profiles, HEA 500 to HEA 300. And immediately I get my connection. Now, as you can see, what it has done is it's taken the first profile, it's extended it into it's removed the flanges. Let me just show this one only. So it has taken the first profile, it's cut it out, it's cut out the web, removed the flanges completely. I'm going to turn it back on now, and it's used extra plates on the side. So you have the continuation of the flanges in a different way. These are artificial flanges for the bottom column, and then it's continued that with other plates. And now at this point, it has created the normal splice between this one and the other one. So this is an extremely useful, handy macro. Once again, like with all macros, you have the ability to enter all your numbers. You can save them away as your company presets, all information related to bolts and plates and welds. And with a few clicks, you can sort out this seemingly challenging situation. Now let's move on to the third steel macro. Now, normally you would have the girts at the outside the outer face of the column. That would be the normal practice, but sometimes the architectural requirements are such that you want the girths to be flush with the outer face of the column. And in those cases, you need a slightly different type of connection where the girths just need to be pulled back and a plate needs to come out of the web of the column rather than from the outside. So this is a different case, and normal, although it's very easy to do, but everybody wants macros to do everything. So our customers requested that we have a flush girth connection, and it's extremely easy to use. You just select the column like the normal girth macro, select girth number 1, girth number 2, and that's it. Your connection is immediate. The girth is pulled back from both sides. The other girth is also pulled back, and your plate is and your connection is made with a few clicks of the mouse. Now let's consider this situation. This is the 4th macro which we've developed for you in this version. Now, usually whenever we have significant seismic forces or significant wind forces, you never do something like this. You don't use these flimsy, rod profiles as your bracing. But when your loads are really low and all you need to do is just make the structure stable, basically, take a little bit of load, then it is common practice to use these rods as bracings, basically. And in those cases, obviously, you want a simple connection, and some standardized equipment is also used. There's something called a hillside washer, which is used very commonly. And we've developed a connection for that. As you see on the screen, it's called the rod bracing connection. I can just select it, select the column, select the bracing, and that's it. It just creates an oval hole inside. I can go on the other side and show you what it looks like. I can zoom in and bring the standard company preset for this particular one. There you go. And basically, as you can see, it places this standard off-the-shelf piece. It's called a hillside washer at that point, and allows the rod to just run through the column. And with the big washer behind it, it allows you to tighten it from the backside. And inside you have details. You can modify the parameters. You can change the hillside washer type. It basically reads from a file. You can have different. You can have generic types and custom types. You can create your own whatever hillside washers you have available in your part of the world. And then according to that file, you will then choose the particular washer. So it's a very convenient connection. It just puts this little piece, which you buy off the shelf, and it takes the rod right through it and right through the column. And then from the other side, it puts this washer, and it allows you control over these parameters. So it's a handy little macro, which you can use whenever you're detailing for lightly seismic areas, etc. Finally, for the steel macros, I want to take you to the knee connection type 3. We already had 2 type 1 and type 2 knee connection macros, but this is requested by some of our customers as well, that whenever you have situations where the profile is coming in at an incline and you want this sort of a connection, it's extremely easy to use. Just select the column, select the beam, and you have your basic knee type connection created for you. You can go inside, you can change the parameters as always. You can use I've just set my, not to waste time basically, I've set my parameters to create my custom connection. You have options, for example, over here, what you can do is you can have different types of haunch styles. So you can have parallel haunches, which does something like this. Let me just show you. So you basically look at this one is parallel to the column and this one is parallel to the beam. What else do you have? You can have the same thing at a particular angle as well, like that, or you can have the default, which is like this. So you have things to play with. You have complete control over the bolts, over the plates, over the dimensions, etc. And once again, a handy macro to use, and we hope you will like it. Now, I want to show you a very important new feature. This feature has been requested for some time now, and we were working on it. And this is the first time it is being released. It's called the bent plate. The bent plate is different from the folded plate in the sense that the folded plate is only folded in one continuous direction, whereas the bent plate, on the other hand, can be folded in different directions by basically joining or opening up pieces of flat plates. The way to use this command is very simple. You just create independent plates first, which will then be joined to each other. So these are all what you see on the screen is 1, 2, 3, 4, 5, 6 plates on the screen. And what you do is you simply use the new command, which is under the sectional plate, under this plate menu. It's called the cylindrical bent plate command. And what it does is it allows you to select 2 plates or 1 bent plate and 1 plate. And when you select them, it automatically joins them at a common intersection. If there is more than one common intersection, then it will ask you to choose which particular one you want to use. So let's see how this works. What you do is you go here. Like I said, you use the cylindrical bent plate command and you click on it. And then it allows you to choose either 2 plates or 1 existing bent plate and another plate. So I'm going to choose this plate and this plate. And immediately it joins them together. And now this is no longer a normal plate, but this is a bent plate. I can continue by selecting this bent plate and this plate, and it joins those 2 together as well. You can see from there, it's joined them together. I can then continue to join this one, this whole new bent plate, and this last piece over there, this one and this one. And now because it sees more than one possibility to connect, one common edge is over here and one over here, it asks me to choose which one I want. So I choose this one. And when I do that, that one is connected. Now, up till now, this could have been done with a normal folded plate as well. But now I'm going to connect this plate to this existing plate, and this will now make it a true bent plate. So let's kind of look at it from here. Go to my command, my cylindrical bent plate, choose this one, the existing bent plate, and choose the new plate. And it gives me 2 options at this point. I want to choose this one, which is the direct connecting one. And you can see that it has now connected this folded piece to this new plate over there. And now for the final one, there's one lying at the bottom as well. I can go and choose the command again and say connect this one to this one. And it gives me 4 options this time because all 4 are touching or can touch theoretically. So I choose this one and immediately I get this very complicated folded plate. Now, even after you have finished with creating this bent plate, when you select it, you see that there are many handles which appear on the screen. So these include these little polygons which you see in the middle of each plate which was used. If you select these polygons, these roundish polygons, then the particular plate which was used for that connection is now highlighted, and its corner points are highlighted. And if you want, you can modify. You can add new points, midpoints. You can add new chamfer points. You can move the points if possible. Like for example, it might be possible in the case of this one. If I select again and I select this one, then I can, for example, move this point somewhere else. For example, that could be a requirement. So this is the first handle with, in the middle of every plate which was used. The second handle are these lines which you see. These lines are the common edges where the plates were bent. And if you double click on these lines, then you have this new feature over here which allows you to bend according to the short edge. So for the 2 common edges might not be the same length. So you can connect the shorter edge, or you can connect the longer edge, or you can make a tapered sort of a connection. You can modify the radius of the connection, the radius of the turn over there, or you could just remove that entire edge altogether, and it's like you'd never connected those 2. So all these editing features really make the creation of these bent plates very easy and very simple. And obviously, the whole idea of 3D modeling is to produce 2D drawings. And as you can see on the screen, all we need to do is just select that element, right-click, and say create the part drawing, and it will create the unfolded drawing of that folded plate, showing you the angles of where it's been folded, the radii, and the lines where the folding needs to take place, etc., along with the material list and everything. So this new feature has really made the drawing production and modeling of bent plates extremely easy, and we really hope you will enjoy it and use it in your various projects. And now for a little surprise. Modeling, is not only about steel and concrete. There is mechanical and there's electrical as well. And these disciplines need also to be modeled if you want to extract proper drawings from our models. And what we have done is this is the beginning of our electrical module, which you're seeing on the screen. It's going to be a very powerful one. It's for modeling the raceways and cable trays and the cables themselves and the routing of the cables and the modeling of consumers and the production of consumer lists, etc., directly from the model. So it's going to be a very powerful module. You can see on the right-hand side that we have commands for creating cable trays, the vertical elbows, 90-degree elbows, specialized elbows, T connections, downward connections, cross connections, basically anything you will need to model your cable trays, and then to modify them by breaking them or joining them or mitering them, etc. And then we have consumer objects to create panels and consumers and all the electrical consumers which you might have, lighting fixtures, etc. And then you have even some support, some macros for creating supports for these cable trays, because they need to be connected to the steel structure or the concrete structure. And you have commands for cable routing as well. You can produce cable lists directly from the program. And of course, you have the general settings area. So this is a very nice beginning, a start, which will allow our users to not just work with steel and concrete, but also work with electrical objects if it's part of their design process. And if it's not, they can maybe add it to the design process. What's great for you is that in this version, we are bundling this preliminary version of this electrical module completely free for you. We just want you to test it, try it, work with it, see if it works for you. Later on, we will think of making this, giving this a price tag. But for the moment, we're bundling it for free with this new version of COMOSYS 2024. And we really hope that you will enjoy playing with these new toys which we are giving you. We have now come to the end of my presentation. I hope you liked what you saw. And to be honest, I could not show you many comparatively minor but extremely useful features because of time constraints. These include improvements in the API, which now allows even more things which can be done with it. I didn't talk about better Grasshopper integration, which includes the ability to create cuts and welds, as well as solids and rebars directly from within Grasshopper. I didn't mention minor improvements in working with our databases. I didn't mention IFC improvements. I didn't talk about many built-in features, many built-in tables for the Russian market. I didn't talk about dozens of small improvements in capabilities of the various commands on the drawing side. I didn't even mention the new ability to put sketches inside table cells, or the extremely useful additions to the project preferences file. And finally, I also didn't mention the new text-based documentation of COMOSYS, which will now be available with this release. All that would have taken another hour at least, and this presentation is already very long. I know typical what's new presentations are 15-20 minutes and showcase 2 or 3 minor improvements, but we at Proya, however, believe in not holding things back and give our customers the best experience that we possibly can. Now, as we finalize this release, we have not stopped working on even more features. 2024 will bring many more exciting features, and we assure you your trust and mental investment will not go to waste. The market is definitely looking for an alternative in this sector. That much is very clear. What is also clear is that if any software can challenge the status quo, it is COMOSYS. I leave you with these thoughts. Please contact our resellers for more details. I'm sure they will be willing to assist you and suggest a way forward which allows you to take this important migrational step with ease and comfort. Thank you.
Hello, everyone. Thank you for that. Thank you for being patient. Thank you for waiting till the end. I'm sorry for the long presentation. Unfortunately, that is a problem we have to face because we are trying to penetrate a market and people want to hear about some details. Only giving the broad picture or only giving the name of the feature sometimes is not enough to convince people of what kind of improvements we have made. So these what's new type videos take considerable amount of time, so I'll apologize for that. There are some questions, as usual. A few questions were not very clear, so I've left them out. Maybe we can contact you later, or you can contact us later. But I'll try to answer the ones which were clearer. So the first question is, do we have can we import from Revit? Because obviously Revit is a very commonly used program, especially for architecture. And the answer is obviously yes. The standard way of doing so is through the IFC file. And by using the IFC file, you can import your architectural models directly into COMOSYS and continue working on them for adding your structural steel or making the connections and producing your drawings or even adding your rebar or concrete, etc. The next question is there model sharing and multi-user? And the answer is yes, we do have a multi-user. It's one of the advanced features which we introduced last time, that we can now, more than one person can work on the model at the same time. And that is very important with very large projects where the load cannot be taken by one individual and there's 2 or 3 or 4 or 5 people or even more people working on the same model at the same time. There's a question about IFC conversion not working properly, and I'm not sure exactly what that means, but what I will say is that with this version, we have made lots and lots of improvements in the IFC. Like I said, I haven't been able to show you half of what we've done in this video. You will have to download the version and try them for yourself. But yes, there have been lots of improvements, lots of additions, lots of bugs have been sorted, fixed. So I hope that whatever it is that you have had in your mind when you were writing the question should have been sorted by now. Then there's a question on, are there macros for ladders and staircases and things like that? So yes, we do have macros for ladders and staircases. They're very easy to use. There's another question about checkered plate and the position. And I'm not very sure. I'll have to check this. I remember working on this, that mirrored checkered plates can get the same number. So I don't want to give a 100% yes at the moment, but we'll check and get back to you on that. Can COMOSYS create horizontal bracings with gusset plates between 2 beams? Yes, it can. There's no limitation in modeling as far as COMOSYS is concerned. You can model basically anything you want, and you can create your user joints out of it. If the question is there a ready-made off-the-shelf macro for doing it, then we don't have it in this version. Actually, we don't basically we don't really prefer those kinds of connections because they create a lot of stresses on the webs. We have some videos on that as well. But in theory, you can always model, those are called boomerang type connections. You can always model for smaller loads, and COMOSYS will be able to assist you in that without any problems. The next question is regarding cloud points. Now, we're developing at a frantic pace at the moment. You can see from this video already, in which half the stuff I couldn't really find the time to show you, that we are basically prioritizing the things which the customers are asking for the most. Now, I know there are some customers out there, but they're very, very few in number, who are primarily focused on point cloud imports. But I would not like to say that we don't have it in our plans, because we do. what I would suggest is please talk to our resellers, tell them about yourself and your needs. And the moment these requests start adding up, then we can immediately assign, we can start working towards those solutions. At the moment, what we have done with this version is what primarily most of our customers were demanding as urgent and immediate requirements for their projects. Similar is the case with the last question is about IFC analysis. Like I said, oh, sorry, this is different. This is about importing analysis-related loads through the IFC file. This is something which is very easy for us. It's not very difficult for you. I would suggest just contact our resellers and give them your requirements. And I think this can be easily implementable in the coming midterm releases, which will be coming out in a few months, maybe even. I think those are basically the questions I want to take at the moment. I once again thank you all for attending. Thank you all for being patient. This is one of the most well-attended webinars, I think, and which is good, which feels good, because it tells me that the interest is there. People want to go into this product. People want to use it and try it and see it as a replacement. So thank you again for coming, and hope to see you all soon. We would like you to be as much in contact with us as you can. Please send in your requests, because we are a very dynamic company and we do take your requests into consideration. So please don't hesitate to contact us. And as much as it's possible for us to do, we'll do it as quickly as possible. Thank you and goodbye.